I will request the sound to be fixed for the umpteenth time. Okay. Generally speaking, if you draw a good picture, what appears to be true is true. So on a kite, by definition, we know that consecutive sides, both pairs of consecutive sides are congruent. So we know that, right? Are there any angles that are congruent? Matter of fact, let's draw the diagonal. Let's draw the diagonal from between the vertex angles. Where the congruent sides meet, those are the vertex angles. And this is the non-vertex angle. And generally what appears to be true is true. If I color these triangles, I have this triangle and I have this triangle. What do you think is true about those triangles? They're congruent. I could pull them out if you want. It won't be a perfect match, but it'll be kind of okay. And if I match them up, they're pretty much the same, aren't they? Okay, so they are congruent. Well, if that's the case, what's true about these non-vertex angles? These are congruent. So if I draw a good picture, I don't have to memorize all the properties. Okay? What else is true about angles 1 and 2? They're congruent. So angle 1 is congruent to angle 2. We don't know why. We know the triangles are congruent. We know that those are the same angles in those two triangles, so they have to be congruent informally. And what about 3 and 4? They're congruent. To memorize the properties to say, well, the angle, the vertex angles are divided into two congruent angles, that's too hard. I just draw the picture. And then I say, oh, well, 1 and 2 are congruent, 3 and 4 are congruent. And if that's the case, if I name this A, B, C, D, what about segment BD? What does it do to angle ABC? That's this angle right here, ABC. What does that segment do? It bisects it. Great. Bisects. Yes, you need the line segment mark. If you want to talk about segment BD, you need that mark right there above it. Okay, so one of the sides would be BC, but you must use the line segment. That's the question, is how do you write it? Notation, because it tells me I'm talking about the segment BC. If I have BC, that represents the length or the measure of segment BC. So we have to communicate. So somebody's decided this is how we're going to do it, and we just have all agreed to go along with it. Okay, so if I have a diagonal, it will bisect the vertex angles. If I put in the other diagonal, I get some other interesting information here. So if I go from A to C, and because I did a nice kite and I'm using my drawing tools, it's a lot easier. What do you think is true about this angle right in here? 90. It's 90. So the diagonals are perpendicular to each other. So I'll write that down. Diagonals, these are properties of kites, are perpendicular to each other. So that's kind of nice. So I know I've got 90-degree angles. And even more than that, if I look at, do I have any more colors there? I probably do. If I look at this triangle, and let's change colors again. It'll be dark. And this triangle, a lot darker than I wanted it to be. What's true about those two triangles? They're congruent. So what's true if I make this E? What's true about segment AE and EC? What's true about those two segments? Look at the picture. What do you think is true? Are they different or are they the same? They're the same. Okay, so you can say AE is congruent to EC, or you can say the length of AE equals the length of EC. So when I have diagonals, one is a perpendicular bisector of the other, and I just draw the picture. Yes. E is this point right here. It kind of was drawn on the segment there. That's E. So the length from A to E, that length equals the length from E to C. So one diagonal, I'm not going to write down which one's which. Just know that one's a perpendicular bisector of the other. When you draw the picture, you'll figure it out. So one diagonal is the perpendicular bisector of the other. So that gives me a lot of stuff to look at in a kite. I thought this was a long lesson. When I put it together, it was a long lesson. So I know all these things are equal. These consecutive sides are equal. I've got right angles where the diagonals intersect. I've got a lot of stuff. So this just gives you the information. Then what you have to do in the problems is apply that information. That's where it gets hard. Yes. I should. I had it there. It just got kind of taken out when I did the colors. Yep, these are all right angles here. So we can look at some homework questions if you have homework questions too. Well, that's everything there is to know about a kite. So I'm going to add a new page. Actually, I have a page added, and I'm going to do trapezoids next. Are we ready? And do you remember what's true about trapezoids? What are they? You have one pair of parallel sides. Exactly one pair. The other sides will not be parallel. So you have one pair of parallel sides. And then because of that, I get a lot of interesting things. I'll go to isosceles trapezoids in a moment, but not quite yet. So if I have a pair of parallel lines, I'm just going to draw some parallel lines here. I'm going to draw a transversal. And then, do you remember what kind of angles these are? Are they, now by the way, when you have parallel lines cut by transversal, you always have congruent angles or you have supplementary angles. It's one of the two. There is no other option. So if you draw a nice picture and you look at the picture, what is true about angles 1 and 2? Are they congruent or are they supplementary? They're both acute. What do you think? Cindy, what do you think? Yeah, they're congruent. You got a 50-50 chance. If one's acute and they're going to be supplementary, which means they add to what? No. 180. 180. Supplementary means 180. Complementary is 90. Okay. They don't look like they're going to add up to make a straight line, do they? Now, do you remember what these angles are called? These are alternate interior. That's right. 1 and 2 are corresponding. This is 1 and 2. This was 2 and 3. But what about these guys? They form V's. 1 and 3 are vertical. Good. So when I have parallel lines, either the two angles are equal or they are add to 180. So what about 2 and 4? Are they congruent? Do they look congruent? This is acute, and this is obtuse. So what's going to happen to 2 and 4? Measure of angle 2 plus the measure of angle 4. They're supplementary, adds up to 180. They're either going to be equal or they're going to add to 180. That's it. There's no other option, which makes your life easy. If you draw a nice picture. If you don't draw a nice picture, then you might be in trouble. But if you draw a nice picture, it's pretty good. So guess what? These are parallel lines. So guess what? This is angle 2. This is angle 4. These are called base angles. Whoops, base angles. That's this pair and this other pair are base angles. So there's two pairs in a trapezoid. But what's true about angle 2 and angle 4? They are not congruent. They are supplementary. So if you take one upper base angle with one lower base angle, they add up to 180 degrees. Because they're parallel lines. That's why I did that little deal over there. So anytime I have a trapezoid, then I know that this upper base angle and this one, lower one, will add up to 180. Same with, let's see, 5 and 6. Yes, well, if it's an isosceles trapezoid, yes. Because I don't know the relationship between 4 and 5. So I think I'll go down to my next figure and talk about the isosceles trapezoids. That's why I have two figures here. A little bit different. Okay, so this is an isosceles trapezoid. Well, just like an isosceles triangle, these parts, those are called the legs. This is a leg and this is a leg. They're congruent. And this is base 1. And this is a base. So I'm going to call this B1 and we'll call that B2. Okay, so we have the upper base, we have the lower base. It doesn't matter which is which. Well, if these legs are congruent, what do you think is going to be true about these base angles? They're congruent. Is that okay, TJ? It's still, is this upper base angle plus the lower base angle down here have to add to 180. Well, if these base angles are congruent, just like in a triangle, what about these upper base angles? They're congruent. So if I take either upper base angle with either lower base angle, they will add to 180. So that's what's true about an isosceles trapezoid. What about the diagonals? There's one diagonal and there's another diagonal. What do you think is true about the diagonals? Okay, I'm going to move that one. And guess what I'm going to do? No, I'm going to rotate it if I can. You get a whole bunch of triangles, yes. No. I want to rotate this. Okay, we'll clone it. Clone. There. And now I'm going to flip this. And what's true about these diagonals if I can grab it? Yeah, they're equal. Only if I can grab it. Being difficult. Well, that's because my board is weird. Let me see if I can grab this one. There we go. You see that they're the same? So the diagonals are congruent. Okay, TJ? Okay. Put that one back there. See if I can put this one back here, which I can. Good. Okay, one more part. This is the mid segment. If I take this segment right here and join the midpoints so that this is congruent to this, and this one's congruent to this one in any trapezoid, call that M. Do you remember how we found that? This is the average of the two bases. So the length of M is equal to 1/2 of the upper base plus the lower base. It's an average. And you get a bunch of triangles when you do some of these things, too. So is that okay? That's what we did last week. I think I've got it all. I'm not going to swear to it. So if you go through the notes, you should see everything there. Yes, if I draw that mid-segment, I get a whole bunch. I get 4 triangles in there. So are there questions on the homework that was due for last week, in particular lesson 5. That was, I think, harder than lesson 6. Cabin question, I don't remember that, but that's okay.
When you could have just measured the cabin and added that. Yeah, I don't remember. You go like this. I just got it out. What's this? What's this? Oh, big on egg. Anterior. Anterior alternate angles.
Good luck. As long as I get it back. Cabin problem. Now, how are you going to study for this test? You're going to go back and look at things. Oh, how did I miss that? Oh, that's lesson 6. That's why I didn't get there. How about lesson 5? I walked around. Now, you should have this out. It's a orange sheet, I think. I walked around and looked at some of these, and a lot of people had the answer for number 4. I can't do that without some work. Well, I should put something in, because if I ask you, what did you do, you should be able to answer that question. Because when you study for your test, you might look at that problem. That would be in R2, I think. How do you do it? Yeah, that's the work. Then the rest is all calculator. I don't care about the rest. I mean, I do, but that's not my main focus there. So I can't do that problem without doing an equation, or at least subtracting. I would. What about number 5?
Number 5?
Yeah, this is the properties of the kites. Okay, girls? You should have your worksheet out. I'll give you a second. This is the orange one. I think it was orange, wasn't it? Yeah. Salmon color. No, it's orange. That one. Orange, that's salmon. That's lesson 4. That one. That's salmon. It's lesson 5. It's orange. I don't know where my extras are either. So, yeah, that's what I thought. Unless you ask me. Now, tomorrow, yeah, we'll do this one too. Oh.
I know how to do it.
I know, you had to be very quiet.
I know how to do it. And I will show the class.
Okay.
Well, I'll explain it. Do it, I don't want to show the class. I want to explain it. The 18's over there, 18, and that's 90 always.
Yeah, these guys switched.
Oh, that's fine.
Okay, you ready? Number 5, I see a lot of right answers, so that's good, but I don't know if it's for the right reason. If this is 18, what's this little angle right here?
90.
So these are equal, x and x. So x plus 18 plus 90 equals 180, or x plus 18 equals 90. I can remember they're complementary. So x is 72. Now, to do y, because this is an angle bisector, I know that this little angle here is 29. And that's a right angle. So y plus 29 also is 90. So y is 61. Good. Now your job when you do your worksheet, because I'm sure everybody here has a question, is to bring a question tomorrow, because I don't know what you don't know unless you ask me questions. Yes. Probably not, because we probably won't be finished with it. I don't know. Remember, I only give you a half hour. Can't get it done in a half hour, then something's wrong. Or it's too long. The cabin problem. Okay. Well, we'll look at it. Yeah, that's your homework. How about number 8 on this? Could you draw your trapezoid? Did you check your answers? I want a trapezoid. and I want one of the bases to be QU. There's more than one answer. And now I have to go in the right order. I, Z. The other base is ZI, or you could say IZ. If you don't have the bar over it, it's wrong. Name the two pairs of base angles. I have angle Z and angle I. I also have angle Q and angle U. Okay. What's my time? Now this is the mid-segment one. How about number 3? How about number 3? These lines are parallel. So how big is X? 60. How big is Y? Now be careful. Y plus this angle here add up to 180. It's not 40. It's 140. They either are congruent or they add up to 180. Were these okay? Okay. Well, let's read the cabin problem. Laddie or Lady and Casey pride themselves on their estimation skills. Take turns estimating distances. Casey claims that the two large redwood trees visible from where they are sitting are 180 feet apart. Laddie says they're 275 feet apart. The problem is you can't measure the distance to see whose estimate is better because their cabin is located between the trees.
Yeah, you can measure with the cabin.
Okay, so we're going to do it in a different way. Okay. All of a sudden, Laddie recalls her geometry. Oh, yes, the triangle mid-segment conjecture. She collects a tape measure, hammer, and some wooden stakes. What is she going to do? So she is going to make a triangle here. Well, that's the stake. She's going to stake that, right? And she's going to find halfway between here and here. And halfway between here and here. Call A, B, C. So halfway between A and B also. And she can measure this, right?
So how do they know the distance between the trees?
Because you can measure this distance. You can make this distance here and find the midpoint, right? You can find that midpoint. You can get this distance and find that midpoint. And this is half of that.
Oh, I get it.
So if she measures this distance, then that's twice.
Multiply by 2.
Yeah.
Oh, yeah.
Anything with this problem? Those are kind of, don't you think they're kind of fun? No. I think they're fun. They get a little, but I wouldn't do it without a calculator.
I'd actually like to know
Which one? How big is A?
Oh, I got
54?
I got confused on H through.
Let's see if H. Well, H is congruent. H is congruent to this one. If I can find I, what's true about H plus I? They have to add up to 180 because this forms a linear pair. Then, you know, I'm going to guess I want this triangle.
H is 49.5.
Is it? Do I know what K is?
Yeah, K is 49. No, K.
I know M and F.
Okay. How do you guys get that? No.
Pardon?
Yeah, K is 49.5 too.
It could be.
It is. We did that. Yeah.
I don't know. I have to work my way around. I, H, I, where's J? Is there no J? N is equal to H plus K. And I don't know if I have to do this. I need to get this one. you can do this little quad. How big is G? Because once I know G, I know that guy. And once I know these two, I get this one, and then I can get this one and this one. So I have this, this, this. I can find M. I kind of have to go through the whole thing. Let's see. I also have a right triangle here. You see that triangle?
Yeah.
So you can find this little angle over here. I kind of have to work, I kind of have to do the whole problem to do it. I can't just jump into it unless I know some things. What time is it?
I 1:55.
Okay. Oh, 4 minutes. 4 minutes. Is B 72? Should be 72. How big is C? C is 108. D is same as B, 72. Oh. Then this is 18. And this is 162. You can find F, which is the same as 18. You know, you find out that they're probably congruent. And you can find G. Oh, I did that already. 162. G is half of that, so it's 81. You just keep going. Good. They're tricky.